Welcome back, ladies and gentlemen, to another video with Mr. Kenton for physical science. I hope you guys are doing well today, and I'm going to be looking at today how we can make Lewis dot diagrams, what they are, and how they're useful to us as chemists and scientists, and telling us information about the atom. Okay, and so Lewis dot diagrams, you could also hear them referred to as electron dot diagrams as well. So if you see either of those terms, just kind of keep that in the back of your mind. But what a Lewis dot diagram allows you and I to do is to identify and represent how many valence electrons an element has. And if you recall, when I say valence electron, we're talking about the electrons that are in the outermost ring of the Bohr model for that particular atom. Now you might be thinking, why is this useful? Well, being able to look at the number of valence electrons for an atom is useful because those are the electrons that are involved in chemical bonding. And so when we think about chemical reactions and chemical changes that take place, that's due to the valence electrons moving within an atom to get to a stable position. Now, in order for us to be able to draw a Lewis dot diagram, we're going to need to know two pieces of information which we can gather from the periodic table. The first thing that we're going to need is the element symbol, right? So you're going to look for you get the name of the element, you're going to go find its element symbol on the periodic table. And then the second piece of information we're going to need to look for is the number of valence electrons. And if you recall, we can simply look at the column number to help us figure that out. And if you don't remember how the column number tells us the number of valence electrons, go back and watch the previous video and take a look at what it says about determining valence electrons. Okay, so that's what we're going to need from the periodic table to be able to draw a Lewis dot diagram. So when we look at those pieces of information, this is what we're able to come up with, right? So you've got aluminum and oxygen. So these are both elements on the periodic table. And you look, and aluminum is element number 13. It's in column 13. And so because of that, it should have 3 valence electrons. So notice we've got the element symbol Al, and then we've got the 1, 2, 3 valence electrons because it's in column 13, right? And then we look at oxygen, right? Oxygen is element number 8. It's in column number 16. So oxygen's element symbol is an O. And then what we're going to do is, because it's in column 16, we know that it has 6 valence electrons. So then we would just go around and we put 6 dots around the element symbol for oxygen. And each of these would represent the Lewis dot diagrams for each of those elements. Now, that gives you examples, but it doesn't tell you what you would have to do if you actually needed to go through and draw the Lewis dot diagram. So, let's take a look at this next slide. Now, in order for us to create or draw or write out a Lewis dot diagram, there are several guidelines or rules that we need to follow in order to do that. Now, the first one, if we know the identity of the element, if we know its name, we need to use the correct symbol, right? If they ask us for sodium, but then we give them the element symbol for magnesium, that's not going to correspond to the appropriate Lewis dot diagram. The second piece of information that we're going to need to do is to identify the number of valence electrons by looking at the group that element belongs to. And like I mentioned, if it's in group 1, 1 valence electron, group 2, 2 valence electrons, and then so on and so forth. It's important here, and this is a distinction from Bohr models, which we've looked at previously, is that Lewis dot diagrams only show the valence electrons. And so it's going to be important that we only draw the valence electrons for that atom. And since we're dealing with valence electrons, we're going to draw no more than 8 electrons around an element symbol for a Lewis dot diagram. So no more than 8 electrons around a Lewis dot diagram. Now, as it comes to order, there is no specific order, but I'm going to give you one here that I want you to follow when you're going through and doing this. So what you're going to do is if you have 4 electrons, what you're going to do is you're going to place one dot on the top, to the right of the element symbol, to the left of the element symbol, and then on the bottom of the element symbol, right? And so as long as you have one dot on each side first, that's okay. Now, if you have something that has more than 4 valence electrons, that's when we look at this last point. So if something like has 5 valence electrons, you would go to the top, the right, the left, the bottom, and then you would go back to the top, and you would pair up an electron. So you should have no more than 2 electrons on each side of the element symbol. Okay. And so those are the guidelines or the rules that we must follow when writing a Lewis dot diagram. Okay, and I know that you guys have looked at these in class. I know I gave these as an example, but make sure that you go through and you draw the Lewis dot diagrams for each of those following elements. Okay, and I would even encourage you right now to pause the video and work on that. And then, check back in. What I'm going to do is I'm actually going to, while you're pausing it, I'm going to go ahead and write out the answers. Okay. Awesome. So hopefully you were able to pause it. Hopefully you're able to go through and draw your Lewis dot diagrams for each of these. But when we look at each of the elements, we've got strontium. Okay, so we got to find strontium. Strontium is element 38. SR is its symbol. So we got SR. And strontium is in column 2, so it has 1, 2 valence electrons. All right, so that'd be the Lewis dot diagram for strontium. For sodium, sodium is element symbol Na. It's number 11 on the periodic table. So we got Na. And sodium is in group 1, so it has only 1 valence electron. Nitrogen is element number 7. It's got an element symbol of N, and it's in column 15, which means it has 5 valence electrons. So we would go 1, 2, 3, 4, 5. So you got 5 valence electrons around your nitrogen. Now, for nitrogen, you could have had something like this as well. You could have had N, 1, 2, 3, 4, or you could have had the pair on the right. Okay, so there are multiple different ways that you could have done nitrogen. I'm just giving you 2 possibilities. All right, for neon, neon is element number 10. It's got an element symbol of, I'm going to do it over here, of Ne. And neon is in column 18, which means it has 8 valence electrons. So we've got 1, 2, 3, 4, 5, 6, 7, 8 dots around neon. That would be the Lewis dot diagram for neon. Okay, one of our noble gases. And then our last one is lead. Now, lead's kind of tricky. Its element symbol is Pb. It's element number 82. And lead is in column number 14. So lead has 4 valence electrons. So 1, 2, 3, 4 dots around lead. And so there you have it, ladies and gentlemen. Those are the Lewis dot diagrams for those 5 examples. I hope this video was helpful. I hope you were able to do well in the practice. If you do have any questions, please don't hesitate to bring them up during class. I'll be more than happy to help you guys out. Thank you guys so much, and I'll see you guys again soon.